In this video, we are going to introduce the concept of derivative in calculus and use first principle to find the derivative of a function. By definition, f of b minus f of a divided by b minus a, which is slope of the secant line joining the points a and f of a and b and f of b, is average rate of change of f of x when x is greater or equal than a and is smaller or equal than b. And limit of f of x minus f of c divided by x minus c as x approaches c, which is the slope of the tangent line to the graph of function y equals f of x at point c and f of c, is instantaneous rate of change of f of x at x equals c. We define f of x minus f of c divided by x minus c as quotient difference of f of x at c. The limit of quotient difference as x approaches c is called the derivative of f of x at x equals c, and it is denoted by f prime of c. Derivative of a function at x equals c is the instantaneous rate of change of the function at x equals c. Let's find the derivative of f of x equals square root of x plus 1 at x equals 3. F prime of 3 is the limit of square root of x plus 1 minus 3 over minus f of 3, which is 2, divided by x minus 3 as x approaches 3. As we know, to find this limit, we should multiply both the numerator and the denominator by the conjugate of the numerator. The limit would be the same as limit of x plus 1 minus 4 divided by x minus 3 times square root of x plus 1 plus 3 as x approaches 3. X plus 1 minus 4 is x minus 3. We reduce the fraction by x minus 3 and we plug 3 into the function. We find f prime of 3 equals 1 over 6. Therefore, derivative of f of x equals square root of x plus 1 at x equals 3 is 1 over 6. This is the same as saying the slope of the tangent line to the graph of the given function at x equals 3 is 1 over 6. One more time, limit of f of x minus f of c divided by x minus c as x approaches c, which is instantaneous rate of change of f of x at x equals c, is f prime of c, derivative of function f at x equals c. Geometrically, it is the slope of the tangent line to the graph of y equals f of x at x equals c. By definition, f prime of x is limit of f of x plus h minus f of x divided by h as h approaches 0. This is called limit definition of derivative or first principle. We can prove limit of f of c plus h minus f of c divided by h as h approaches 0 is the same as limit of f of x minus f of c divided by x minus c as x approaches c. Simply by assuming x minus c equals h, we can prove these two are the same. Let's find derivative of two functions using first principle. The first one is f of x equals 2x plus 5. F prime of x is limit of f of x plus h, which is 2x plus h plus 5, minus f of x minus 2x minus 5 over h as h approaches 0, which is the same as limit of 2x plus 2h plus 5 minus 2x minus 5, 2h over h as h approaches 0, that is 2. As we expected, the derivative is the slope of the line. Let's find the derivative of f of x equals x2. F prime of x is limit of x plus h to the power of 2 minus x2 over h as h approaches 0, which is the same as limit of x2 plus 2hx plus h2 minus x2 over h as h approaches 0. This can be written as limit of h times 2x plus h over h as h approaches 0. We reduce the fraction and we replace h with 0, we get 2x. This means derivative of x2 is 2x. Let's recap what we've done. Limit of f of x minus f of c divided by x minus c as x approaches c is called derivative of f of x at x equals c. It is the instantaneous rate of change of f of x at x equals c, and geometrically is the slope of the tangent line to the graph of y equals f of x at x equals c. Limit of f of x plus h minus f of x over h as h approaches 0 is called derivative of f of x, and it's denoted by f prime of x. This limit exists only if the right side and left side limit at h as h approaches 0 exists. In order to have the derivative of a function, the function should be continuous at the given point. Thank you.